Hi, hello. Anyone hear me? All good? Cool, cool. Okay, so I'll introduce myself. My name's Luke Orford. I'm a jewellery CAD designer. Um, I'm hoping that this course I'll be able to teach you everything that you need to know about creating jewellery through CAD design, how to turn your designs into reality, for making them into renders, so you can create photorealistic renders, and also be able to create manufacturable models so that you can create your projects, create your jewelry, and be able to sell them to whoever you wish. We'll look at some signet rings. They're quite simple, to be honest with you. It's a very, signet rings, a very simple piece of jewelry. They're quite good at telling stories. They can be very personal. They can be something plain. They can be really complex. But most of the time, when you look at them, it's just a simple table to your ring, nice profile, and it can either be hollowed out or it can be solid. You can just see under here, it's slightly hollowed out. I'll be showing you how to do that at the end of the lesson. Just, it's kind of stuff of like, if you're designing a ring and it's going to be made in 18 karat gold, you want to reduce your weight because you want to save money, especially with the prices of gold. Even with the prices of silver today coming up to £1 a gram, it's pretty ridiculous. So you want to be able to save weight where you can. So we'll go down from our top curve to our table curve, go down 2 mil, and then down to the bottom of our shank. So as you can see down here, this is where our shank profile curves end. I think let's go. I'm going to have about a 4 mil thickness down at the bottom of my signet ring. So because I'm doing one side, half 4 is 2. So I'm going to go 2 mil away from my front profile curves. And then I'm going to draw straight across, hold the shift key so it locks to the diagonals, and click. One. So in our perspective now, you can see I have a new curve. This is what acts as the cage, the skeleton of your signet ring. From this curve, we can use the push-pull function. We use push-pull, which is these 2 little gents down here, pushing and pulling. This allows us to select our surface. So if you have a curve on the surface and it's flush to a surface, it allows you to select a part of that surface to extrude it or emboss it. So I'll show you a quick example here. So say the outside of this curve I want to extrude. So if I click on the outside, it allows me to extrude the outside. It allows me either to do it negatively or positively. When you're going into the thing, you'll see that a red silhouette appears, and obviously it doesn't appear when you're going. So there you go. You can extrude it. You can extrude it straight up. The same. If we want to do it for the inside curve, we run the same command again, and then we can extrude the center. So depending on which area you click in, depends on which area you extrude. Just a quick one so that you know, down at the bottom here, it says yours, when you run it for the first time, it might say something like /1000. That's the amount of samples it's going to render to show your image. So it will be constantly rendering. This is what slows your computer down. So I changed mine to 50. So if you just click it, you see it comes up with a number box. Then you can change the number, like 20, but we're going to do 50. So what happens is, when things render, it's called render passes. So it'll render in a pass, and it will do it a certain amount of times. We're telling our ray trace viewport that it's going to render 50 passes, and then it's going to stop, and then you won't be using resources on your computer. So right now, like that, it stopped rendering, but as soon as I move my camera, you see it kind of slows down a bit. It thinks about it, and then down at the bottom, it will start rendering the passes again until it gets to 50, and then it will stop. if you imagine a rope in your head, it's like 3 or 4 into kind of twined cylinders. Basically, they're being twisted round. So what we're going to do is we're just going to recreate that. So say you take that rope and you cut it straight down the middle. You're going to take the profile, the cross section of that curve. So if we were to imagine that, it's going to look something like this. It's going to be 4 circles. Make sure I've got the right thing. So transform, array, polar, turn off center because I don't want it to snap to the center, and then 4. So this is what your profile will look like if you cut your curve in half. Your rope in half. But we don't want these intersecting sections in the middle, so we're just going to trim those out. So select everything and then just trim, and then we have this nice little shape here. Join it so it's a solid curve, and then we want to move it into the correct positioning onto our curve. Because we know that that's the center of our curve, we can select it and we can make sure on snaps on, and we want to select to the end of our target curve, the curve that's the bangle length. And you can see, because I made my spiral 4mm in diameter, I made sure that my profile curve was the same diameter going across, so you can see that it touches there. Then we just do a sweep 2 rails. So surface, sweep 2 rails, select our curves, select our profile. Now you have straight bit of rope. So when I go transform, flow along curve, select my solid, right click, and then it asks for the base curve, and then the base curve, you can see it's sitting in there in the middle. That's our base curve of our bangle. There's analyzed as flat, and then we select our target curve. And then it thinks about it for a second. And you've got 2 different ways of doing rope bangles. And then also we can stick a ball, because we know there's a curve at the end here, and we have end snap on. We can easily just take our sphere, know that we're snapping to the end, and just draw a sphere, something like that. Do it on the other side. Do the same here. He says, if I could snap to the end. Just copy those across, that would be quicker. And you got two very simple kind of taut bangles, but with quite a kind of cool way of flowing an object across that curve. Thank you. Yeah, look forward to working with you all.